Okay, example 7 is just a word problem involving some of these circular measurements we've been dealing with. All right, so when we look at this, it says NASA is tracking a satellite traveling a circular orbit 320 kilometers above Earth. It can only be tracked while it orbits through a pi/6 radian angle. The radius of the Earth is 6,400 kilometers. What is the distance the satellite travels while it's being tracked? So let me do a little bit of artwork here. It's not going to be good artwork, so don't get excited. All right, so I'm going to make the Earth blue. There's the Earth. I already promised bad artwork, so I've succeeded in there. So let me make the Earth bigger. So there's the Earth. Okay, we got a satellite circling Earth. The Earth's radius is 6,400 kilometers. So if I were to draw the radius of the Earth in, there's the radius of the Earth. We know that is 6,400 kilometers. Okay. We have this satellite orbiting Earth at a 320 kilometers above the Earth. So the satellite's orbit is out here further, so it's the radius of the satellite's even bigger, right? It's the radius of the Earth plus that 320 kilometers. And I'll see how close to center I really am here. So the satellite's orbit, let's put the satellite's orbit in a green color with a dashed line. Let's make it 10. All right, let's see how good I am here. That's not bad. Off by a little bit. So there's our satellite orbiting the Earth. Try to get it better on the center here. Okay, there's our satellite. And we know the satellite is positioned exactly 320 kilometers above the Earth. So that's how long that is, right? Now the problem tells us that the people tracking the satellite can only track it through a pi/6 radian angle. So if I were to draw a picture of this pi/6 radian angle, I'm going to draw it right about here, like so. Okay. And I didn't really, you don't have to draw it to scale. Pi/6 is about 30 degrees, all right, in case you wanted to know that. But the whole idea is that you get a picture of this drawn. It doesn't matter what the picture itself looks like. But that right there represents, so the satellite starts here, gets tracked all the way around to here, and then they lose track of satellite. It's outside of its radar range or whatever they're using to communicate with the satellite. All right? So as it's over America, they're tracking it. When it gets outside of America, all the way around here, they got no idea what's happening with the satellite until it gets back to this point. It keeps going around the Earth. Right? So that's what's happening in this problem. All right? What is the distance the satellite travels while it's being tracked? So basically it's asking for the length of this piece right here. Right. And that's just an arc length problem. And the two things we need for an arc length are the central angle in either radians or degrees and the radius of the arc. All right. So the radius of the Earth is 6,400. So if we wanted to know this distance from here to here, we would use that radius, but we want to know this one, so we're going to have to use the whole radius, right? So we're going to add those together. Yeah, it's just two segments added together to make the whole radius. So the radius of the satellite orbit is going to be 6,400 plus 320, which is 6,720 kilometers. The angle, the central angle, is pi/6 radians. Remember, with arc length, you have to choose which formula to use. There's two formulas to use. One is if you have the angle in degrees, one if the angle's in radians. When the angle's in radians, the formula is arc length equals angle times radius. So we simply have to multiply those two numbers together to get our distance covered by the satellite while it's being tracked. So the arc length, the distance traveled, is going to be pi/6 times 6,720. And now I'm just going to punch this in the calculator. Again, pi/6 is a fraction, so pi divided by 6 times 6720. So I can type it just like that. Pi divided by 6 times 6720 comes out to 3,518.58. Let's go nearest whole number, so 3,519. 3,519 kilometers. The total distance it travels, we'd have to find the entire circumference of that orbit, right? But we're only taking a portion of that circumference. And again, this is the formula if we get the angle in radians. If they had said 30 degrees instead of pi over 6 radians, now we'd have to use, let me just show you that. Suppose A is equal to 30 degrees, which I already told you is the same thing, right? Then the formula would have been arc length equals angle over 360 times 2 pi r. So we put 30 here, we put 6720 there. So 30 times 2 times pi times 6720 divided by 360, the exact same answer because that's how far it travels. Again, depending on the angle they give you, how they give you the angle, there's two different formulas to use. It's your job to pick the correct formula and then evaluate it correctly. So be careful that you're doing that properly.